In this video, I'm going to talk about general graph search algorithm, and I'm going to talk about DFS and BFS. In general search algorithm, we need to have a structure, a queue or a stack to keep track of which vertex we want to see next, and a list of visited that holds the elements that we have visited. We start by putting the starting node into our structure. Then, while the structure is not empty, we take a vertex out of the structure, and if that vertex is not visited, we're going to add it to the visited list. We're going to see if that v that we took out was the goal. If it was the goal, we're going to return that the search was successful. If not, we're gonna go through all of the neighbors of the vertex. Let's call them v2, and for all of those v2, if the v2 is not visited, we're gonna put it back into we'll put it into the structure, and we do this while loop until either structure becomes empty or we return success. Okay, let's get started. And also, before we continue, I have to mention that I'm gonna put the elements into our stack in alphabetical order. So if I see A and I want to put the neighbors of A into my stack, I'm gonna put in order B, D, G. So it really depends on the question that you're solving to go by which order. You can go B, D, G or G, D, B. It solely depends on the question. Okay, the first thing that I said I will add to the stack is going to be A, because A is my starting point. Then I take A out of the stack and I compare it to the goal. It's not the goal, and it's not been visited, so I'm gonna put it into the visited list, and I'm gonna add all of A's neighbor in ascending alphabetical order into my stack. Okay, now I'm gonna look at all of A's neighbors, which is B, D, G, and then compare it to visited list. If they have been already visited, I'm not gonna add them. So B, D, G are not in the visited list, so it's acceptable to put them in the stack. And because stack is last in first out, I'm gonna take G out as the element in the step. Because B was added first, then D, then G. So G is the last element that is added to stack. So now I'm gonna take G out. When I take G out, I'm gonna compare it to the visited list to see if I have G in my visited list. I don't have it in my visited list. I'm gonna put it in my visited list. Compare it to the goal. It's not the goal, so I can move on and put the neighbors of G into my stack. So the neighbors of G are A, D, and I. So when I want to put it into my stack, I'm gonna see that if some of them are visited, I'm just taking them out. So A is already in the visited list, so I can't add A to my visited list. So let me take that one out, and D and I are not in the visited list, so that is perfectly fine. Then again, the last element that is added to our stack is this I. So when I take this I out, I put it into my visited list, and I can declare that one as the goal because our goal was I, and that's how you would use the first search to find some node in your graph. And also see that how depth first search worked. It started from here, it went to G, it went to I, it went into the depth of our graph. That's why we call it depth first search. Now let's consider breadth first search. So here I have an example of breadth first search, and again it's just like an extension of this graph search general graph search algorithm, which now we put Q instead of our structure, and we do exactly the same operations. So we start with the starting node, we put it in our queue, and we take we take the element in the queue out, which is A, and we put it in our visited list because it's not been already visited, and it's not our goal, so we have to move on. Then the next thing that we do is to add all of A's neighbor to our queue, and again I'm adding stuff to the queue in alphabetical order. So B, D, and G, none of them have been already visited, so I'm not gonna take anything out of this adjacency list. Then I'm gonna go to take the next element out of the queue. The next element that I can take out is gonna be B, because Q is first it's gonna be first in first out. So the first thing that we put into our queue was B, so now I'm gonna take B out, and since it's not visited, I can add it to the visited list. I check it against the goal, it's not the goal. Now I'm gonna add all of B's neighbor into my queue. So all of the B's neighbor are gonna be A, C, D, and E, and mention that D here, A here has been already visited, so I can take A out of this list, and I'm gonna take the next element that I can out of this queue. So the next element is D. Now when I take D out, I see it's not visited, so I can add it to the visited list. I check it against the goal, it's not the goal. Now I'm adding all of D's neighbor into the queue. So all of these neighbors are here, and I go through the list that I have here right now, and if some of them are visited, I'm gonna take it out of that visited out of that queue. So A is gonna be out of the queue, because actually we don't put it in the queue at the beginning, and then we take B out because it's been already visited, and pretty much it. Okay, so the next thing that we take out is gonna be G. So G is gonna be out. We compare to our goal. It's not our goal, so we add it to the visited list, and we add all of G's neighbor into our queue. So G's neighbor are A, D, and I. So we put A, D, and I here, and we again compare these elements to the visited list. A and D have been visited, so I can't add them to my queue. This one is gone, and then this one is gone as well. Okay. Now the next one that we take out, it's going to be C. C is not visited, so we can't visit it because it's not our goal. We're not going to return success. So we're gonna add all of the C's neighbor into our visited list. All of C's neighbor are here, and we put them into our queue. Again, let's go through this list and see which ones have been already visited. So A and B are visited, so we're not gonna add them. Then G has been already visited, we're not gonna add G, and E and H and I are not visited, so we can add all of those. All right. Now the next thing that we do is to take the next element out of our queue. The next element is going to be D, but D has been already visited, so we're not gonna consider that one. Then E, we consider E. E has not been already visited, so we're gonna visit E, and since it's not goal, we're gonna add all of E's neighbor to our visited list. So all of E's neighbors are B, C, and D, and as you see, B here has been already visited, C has been visited, and D has been visited. So we can't add any of E's neighbor to our visited to our queue. Then we move on to the next thing that we can get out of our queue. It's again E, and with the same logic, we can't add any of the elements adjacent to E to our queue. So we're gonna move on to the next element, which is gonna be G. We look at G, and we add all of its neighbors to our queue, and we declare it as visited because it's not been already visited and it's not our goal. So G's neighbor are here, and we want to add it to our visited list, and as you see, A is visited, D is visited, but I has not been already visited. So I'm gonna take these two elements out and put only I into the queue. Then the next thing that I do is to get the next smallest one out. I mean the next element of the queue out, which is going to be H. H has not been already visited, so I'm gonna add H to my visited list, and I'm gonna add all of H's neighbors to the priority queue. So H's neighbors are D, F, and I. And even I go here, Since D has been already visited, I'm not gonna add D to my priority key, so let me take D out of here, and I only add F and I to the queue. Then I'm gonna take the next element out, which is gonna be I, okay, and I add it to the visited list because it's not been already visited, and there you go. Here is the goal that we were looking for. And also mention something really nice about BFS. BFS goes layer by layer. So we saw A, we saw B, we saw D, we saw G, we saw C, we saw then E, and then we saw H, and then we saw I. So we kind of went in a layer manner to visit our nodes, okay. But versus in the DFS case, we went to the depth of the graph to find the goal. So that's why they call breadth first search, because it goes through the layers of the graph, and that one called depth first search because it goes to the depth of the graph. And that's how you use BFS and DFS.